Hello and welcome to another video of computer science. Today we're going to be solving October-November 2022 paper 4 practicals. So we've completed the entire Major series of 2022. So we're going to be going on and starting with October-November this time. Okay, so just to save some time, I've already created my Python project using PyCharm and everything because I'm pretty sure that by now everyone is actually familiar with the question creation and the folder creation and all the processes. If you aren't, then you might go ahead and want to check out the previous videos that I've done regarding 9618 question papers, especially paper 4. Okay, so the text file integerdata.txt stored to 100 integers number between 1 and 100 inclusive. A program is required to read this data and performing a search and sorting on the data. Okay, so write a program could declare a 1D array data array with a space for a 100 integer values. Okay, so I'm just going to go ahead and open PyCharm and let's just go ahead and create a new file. Okay, this is named question1 underscore n22. Okay, so our new array is to be named data array. So I'm just going to go ahead and copy this since I'm doing this. Okay, so this is a interesting thing that some of us might actually encounter while kind of performing this. You might want to go ahead and if you see some sort of an error like this in your exam, you might want to go ahead and click on configure interpreter and then choose the Python version that's available. So in my computer it's 3.1. I should be updating it to 3.12 or 1.3 because that's the latest one, so which I'm going to do very soon. Don't worry about that. So data array is going to be a space for 100 integers and it's a 1D array, okay? So I'm going to be doing ahead. Let's to it. So there's no initialization with this array. So if you don't initialize an array and just write, let's say 4x in range this much, then the problem that's going to arise is that it might just end up putting the data values as a string. So what I want to do is we just want to say that initially it's 0 for x in range, then you're going to put a 100. Okay, so that's going to be data array. Procedure read file must read from the numbers and text file and store each one of them in the array and use appropriate exception handling. Okay, so there are actually a couple of methods to do this sort of a file exception handling. Okay, and in this video, I'm just going to be taking the opportunity to go ahead and just explain to you all of them. Okay, so the first one is something that we are pretty much familiar with. Okay, so def we're going to do read file. So the parser read file must take the numbers from the text file, okay, and store it using exception handling, okay. So over here, the first method is obviously going to be try and except, okay. So we want to do is try except IO error. That means this is a specific error that we want to go ahead and focus on. Print file not found. Okay, so this is the classic method. So then we're going to be doing file and this. So I think we're pretty much familiar with this because we've done this a couple of times in the past paper. Another method that you might find out in a few mark schemes is that we are importing OS library. So import OS, and then we're going to be doing that if os.path.exists, and then you're going to be naming your text file in this case. So it's going to be the text file integerdata.txt. It automatically appears. Then if this is the case, that means if this condition is true, because this built-in function returns true, that's when you're going to be going ahead and doing, kind of like, let's say, for x in range, and then it's going to be reading the data from the file. Okay, and the last one, which I think is the most efficient, is using Python's with. Okay, that's one of the most efficient ways to do it in Python. So you're going to be doing is with open. Then you're going to put your file name, which is integer.txt, and you want to open it for reading as file. Okay, and then you've got a data array. So you want to go ahead and append every element of that file. So you're going to be doing this file read split lines. Okay, so you want to do is file read split lines. It's going to be going ahead and splitting every line of the file itself. Okay, and then that's pretty much it. This is literally the only line you need to write in this. So this is like, the most efficient way to do it in Python, okay, and store it in the array. Now, if the question specifically says that use exception handling, if you don't have the file that's present, okay, then this is going to be returning false. Okay, this is going to be returning false. So this automatically does the exception handling for us. But according to the question paper, it's best that if you just use the try method. So we're just going to be sticking to that for today. So try file open integer data.txt read. Okay, so then we're going to be going ahead and just reading through the file. So we're going to be doing for x in range 100 because it's the length of the array. What we want to do is data array x file dot read line strip. Okay, so that means it is just a kind of doing that, except we want to do an IO error and print file not found. All right. Okay, so once the data has been read from the file, it will go ahead and automatically do what? Is going to be going ahead and assigning this as a string value because it's coming from the file. And Python will automatically update this value. So what we want to also do is just do data array x is then integer data array. Okay, just make sure you go ahead and do this as well. With that being said, this line is done. So let's go ahead and move on to the next one. The function find value as an inner number. And so the number must be a whole number between this. The function then returns the number of times the input array appears in this. So use find values. So def find values. So it takes a so we're gonna say that data to find takes the integer input from the user. So integer input enter the value to find. Okay, so what we want to say that this should be put inside a validation, right? When it's validated. So while let's just use the while true method to do this. So if data to find, okay, so if this is less than 1 or data to find is greater than 100, then we want to go ahead and okay, so we want to validate it that we want to break this loop if kind of the condition goes false in this case. So if we want to say that if it is greater than or equal to and it is going to be lesser than or equal to 100, then we want to use the break command and it's going to be breaking kind of the loop. Okay, so once that is done, then we want to go ahead and run a for loop for let's say I in range 100 because it's the length of the array. We want to go ahead and search for a value. So let's go ahead and write count. Okay, so if no, not data array I is equal to data to find, then we want to go ahead and do is we just want to increment count in this case. Okay, so for the 100 values, if we find the data, then we just increment count in this case. That's it. And we want to just return count. That's going to be it pretty much. Okay, let's move on to the next part of the question. The program needs to call read file and find values from the main program, return the value from file and must output with an appropriate message. So first it's going to be calling read file, then it's going to be going ahead and calling find values, and it must output it with a valid message. So the number of times the data value was found, you can just write any kind of message you want, and then I'm just going to go ahead and call find values here. That's it. It's going to be going and printing out everything and use the number 61 as an input. So let's for sure run this. Integer, the int argument must be a string, like an object, not a list. Oh, okay, so the mistake I've done here is that I should also use an x here. That's it. So enter the value to find 61. The number of time it was found was 2. So it looks like it is working perfectly fine. Okay. So the procedure bubble sort needs to perform bubble sort and then print the contents of the sorted array, right? The procedure and call it in the main program. So we need to go ahead and do a bubble sort algorithm. So bubble sort algorithm into this. Now, in case of the bubble sort, you can go ahead and pass it as a global, but I don't think we need to do this. So let's just go ahead and do it. So we're going to be doing an efficient bubble sort algorithm. You could use two for loops and increment through those, or use the while method. So the pass, or kind of the more commonly said boundary value, okay, is going to be basically length of the array -1. That should be 99. You could also do that. So no swap. So this is going to detect when a swap is detected. So while not no swap. So we want to do is now at the start we change it to true. Okay, and then we do a for loop inside this. Okay, so for, let's just call it again I in range, and then we do the boundary. Okay, so in the boundary, okay, so what we're going to do is you could do from 0 to boundary, actually 0 to boundary, or it's actually the same thing. So if you do that, if data array I is greater than, I think it says to do it in ascending order. Okay, it doesn't say anything, that means it has to be in ascending order. So if I is greater than data array I plus 1, that's when you're going to be using a temporary variable, temp data array I, and in data array I we just swap it to I plus 1, and in data array I, or you could, instead of creating a temporary variable, you could just do data array I and data array I plus 1. Just swap it like this in Python. Okay, now this is specific to Python. Okay, it depends on what programming language, like Java, you're doing. If you're doing it in Java, it's a little bit different. So make sure you do it according, or Visual Basic, depending on what programming language you're going to do. And then if a swap takes place, then obviously no swap is now going to be false. Oops. And outside this for loop, okay, we have to do this outside the for loop. We want to go ahead and do is boundary is minus equal to 1. So we decrement the boundary by 1. All right, so we're going to be decrementing the binary this by 1, and we'll print the contents of the sorted. So it prints the content of the sorted arrays. Okay, so once it's done, then we're going to be doing print sorted array, and then let's just go ahead and print data array. That's it. All right, so I think that should be it. I don't think the question, okay, the question never told us to kind of call this. If we were to kind of call this, terminate it, let's go to the Python console. Okay, can we do it this for this one? Okay, so okay, the Python console is supported. Forget it. Let's just do it this way. Bubble source. Let's just call this. So define, it was 61. Oh, there we go. The sorted area has been done. So this is a unique way. If you want, you could kind of swap this. This is actually kind of not taught at this level. Like, you're assumed to do, kind of very basic or upper beginner skills in Python. If you want, you could just learn this, and this is a very easy way to do this. Saves you a couple of lines. Okay, so let's move on to question 2 underscore n22. Okay. So question 2 in this case is object-oriented programming. So let's just go ahead and do that. So class card and hands. It's just two. This we've got a class of cards. It's not important to read the question, even though you should. But during an exam, it's best just ignore it. And the important things are stated over here. So first things first, you always need to go and do, take number and color as parameters. So you want to go ahead and create a class named card, and inside it's a def. Oops. In itself, you want to go ahead and do is number p, and we want to do color p. Right? We want to go ahead and do color P. And then we want to do is self. Obviously, we need to force encapsulation. So number is number P. Self color is equal to color P. Okay, so that should be it. Then we need to write it for get number, and it should be returning the number. So what we're going to do is return self dot number, and def get color, it should be returning self dot color. Okay, number and color. So once that is done, the program is tested with the following. So it has created number 1 red, number 2 red, 3 red, 4 red. So it calls on a few instances. Write program code to declare each of these cards as a variable of type card in the main program. Okay, so we need to go ahead and do a variable card to declare each of these cards. Okay, so you've got the card number over here. So we've got a few reds over here, then a few blues over here, and a few yellows. Now, I will agree to some of the students who said that this question was actually not kind of properly phrased, because in the first kind of instance, it might look a little bit confusing. But the thing is, if you go back to the question and kind of read about the class of card, it stores the card number and card colors. It's between 1 to 5 inclusive. And you can see that each color group, so if you have one color group, that means that is one card. Then this is another card, each card having different numbers. So that's what you're supposed to do. So you're supposed to create different. So first card, in this case, it should be, so we've got a card. So in this case, my first card, so the card number is 1, and the card color is red. And then I want to go ahead and just kind of have this copied, and just replace this with a 2. Okay, so then we want to go ahead and do second card. Obviously, we want to change this variable name. Third card. All right, so that should be going ahead and going to 3. Okay, so for the red cards, okay, let's make it a little bit easier. So first, I'm gonna call it first red, first second red, and third red. Okay, I get it. It's a little bit time consuming, but this is the only way that you're supposed to do this at this point. Okay, so fourth red, and then we've got another which is fifth red. So card, obviously. Okay, why am I retyping it? And then we put a 5 in it. Okay, so then we're going to be doing for first blue. So first blue in this case again. So this is going to be 1, but here we just change it to blue. Let's copy this to second blue. Copy this statement. So this. Then we're going to be doing third blue. Third blue. And then you've got a fourth and fifth blue as well. Do we? Oh no. Oh, we have five blue. One, two, three, four, five. Okay. Four blue card and got a fifth blue. And then finally we've got five yellows. What instead of okay, oh okay, I'm actually kind of the joker here. So for y in range 5, we could just do this. Okay, we couldn't because we have to give separate variable names. Okay, ignore this. So we've got first yellow card, so it's going to be 1, and we've got yellow. So I'm just going to copy this. Okay, and we gotta do second yellow, third yellow, right? Fourth yellow, fifth yellow. I think okay. I think that is pretty much it for kind of all the cards. So now we gotta go ahead and do is write the to hand and its attributes and constructors. Okay. So does it do anything about inheritance? Okay. So it doesn't inherit. So we just gotta go ahead and do a class hand. So class hand. So the class hand is going to go ahead and takes 5 card parameters as parameter. Okay, so 5 card objects and assigns each to in the cards array, initialize first card and number of cards to 5. Okay. So first we gotta do is card 1, card 2, card 3, card 4, card 5. And we gotta do is self. So the names are gonna be first card is initialized to 0, and we've got number of cards, so self underscore number of cards is initialized to 5. Okay, and then we gotta go ahead and declare a array name. I think it's named card or cards. Okay, this is named cards. This is a array. So for x in okay, so we cannot do for x in range in this case because we've got different values to kind of assign. So what we want to go ahead and do is self underscore cards. So append. You're going to be doing card 1. Okay. And then this exact thing 1, 2, 3, 4, 5. You're going to do card 2, card 4, and card 5. Okay, so we're going to be appending them to all of this. Okay, so now it will tell me that, okay, so constructor takes an index as parameter, returns a card at that index. Okay, so it's going to be doing def get card self, and it takes index as parameter. Index. Now remember, in arrays, the indexes or the indices actually, sorry, the indices are kind of +1 always, right? So what we want to go ahead and do is return self dot underscore cards index -1, right? You're going to go ahead and take index -1 because if you're entering 0, that means you want to go ahead and if you're entering 1, right? You want to you do card number 1, so that's at 0. So you want to do index -1. Just be careful of that. Okay. So once that is done, 2 players are declared with 5 cards each. Player 1 has the cards 1 red, 2 red, 3 red, 4 red, 1 yellow, and player 2 has these. Write program and declare player one has declare player one and player two has object of hand with the cards indicate. So player one is a object of hand and it has one red. So it's going to be having first red. It's going to be having second red. Let's try to move that. Then it's going to be having third red. It's going to be having fourth red, and finally it's going to be having uh, first yellow. Okay, so that's for player one, and that's for the class hand. Okay, so then we want to do is for player two is for hand, and it's with yellow number two, so that's going to be second yellow. Then we're going to be having third yellow, so that's going to be third yellow. It's going to be then fourth, so fourth yellow. Then you're going to be having fifth yellow, and finally we're going to be having first blue. So these are the two players that are kind of initiated at the beginning. Okay, so now the function calculate value takes the player hand as a parameter and returns a score calculated using the following rules. If the card is red, 5 points are added to the player's score. If the card is blue, then then it's 10. If it's yellow, it's 15. Okay, so then we're going to be going ahead and do that. 15. Okay. So if that is the case, we're going to be doing a calculate value. So def calculate value. So it takes player hand as a parameter and returns a score. Okay, so it takes player hand as a parameter. So what we can go ahead and do is we're just going to be taking an input parameter player hand. Okay, so now what we want to do is we want to say that the score of the player is 0 at the beginning, right? So if it's red 5, it's blue 10, then 15, and then so on. Okay, so what we want to do is we want to first know what the player card is. So for player hand, okay, so for player hand, we want to go ahead and do is we want to get card, right? Oh, sorry, we want to go ahead and do is we want to go ahead and do get color in this case. So we want to go ahead and do is get, oh no, get card, that's fine, right? We want to go ahead and see what card the player has. So return self dot cards index, then we've got the card num. We've got this, we've got this, we've got the 5, we've got the cards over here. We need to know what card it is. Alright, it's okay. Then we want to go ahead, then we want to find the color of the player. So player color, or player card color, whatever you want to call it. So we want to go ahead and do is choose the card. The card is red, it adds 5. If the card is this is at 10. If the card is yellow, 15 points are added to the player's score. So it's added to the player's score. Okay. This is the card number, obviously. So this is the card number. Okay. And the number of each card in the hand is added to if the okay. The number of each card in the hand is added to the player's score. Okay, so we also need to find out what color the player has. So what we want to go ahead and do is get card. Okay, index. Oh, so we need to output all the cards. So for X in range, so we want to go ahead and set out. So each player has around 5 cards, right? So for x in range, then we've got 0, 1, 2, 3, 5. Okay, so x in range 5. We want to go ahead and find out the player card first. So player hand dot get card x. We want to find out what card the player has. Then we want to go ahead and find out the score of the player. So what I'm going to do is we're going to do player hand. Okay, so can we do the inheritance? Okay, so player. Okay, so now the player card is a card object, so we can work with this right now, right? So with that being said, what we can do is we're going to do for score player card dot get number plus that score is added, right? So the number of each card in the hand is added to the player's score. So we first did that. Okay, that's that job. That part of the job is done. So now what I'm going to do is the card color. Okay, so we want to also get the card colors from player card. What I'm going to do is get color. I hope I've written that method. Get number, then you've got get color. Yes, I have written it. So we want to do is get color. So if card color is equal to red, what we want to do is with score, we want to go ahead and add 5. Else if card color is equal to blue, then to the score, we want to go ahead and according to the question, add around 10. If then you've got a card color. If the card color is, sorry, not green, yellow, we want to go ahead and add 15 to the score, right? So we're going to do the score is equal to score plus 15 to it, right? And then with that being said, outside the for loop, we just want to go ahead and return the score because the question says that it returns a score, right? So amend them by using the function calculate value for each of the two players, and the player with the highest score wins. Okay, so I'm going to identify the winning player, or if the game was a draw. Both players having the same number of. Okay, so you got to do a little bit more work. So that was a lot of work in this question. Great. So now we want to go ahead and calculate values for both of the players. Okay, so player one score. So you want to go ahead and do is want to go ahead and calculate value, and that's going to be player one. Player two score. That's going to be calculate value, and that's going to be player two in my case. All right. So what we want to do is if player one score is equal to player 2 score, then we want to go ahead and print game was a draw. Else if player 1 score is greater than player 2 score, then we can say that print player 1 wins. And finally, if that's not the case, that means obviously player 2 has won, so player 2 wins. That's it. Let's try to do this. Okay, so it just says player 2 wins. Write the function for each of the players with the highest score wins. So the only thing, so what we should be doing is to make it a little bit more fair. What we can do is print player one score, and then we just go ahead and print player one score, and print player two score, and then we just go ahead and just do player two score. All right. So obviously player two wins. So it looks like the program is working fine in this case. So the confusing part is we take the player hand, that means the player, and extract each card from it. And from that card, now, first of all, this is a hand object. When you put it into player card by using get card, it turns into the card object because it's returning. When you do get card, it just does the index -1 thing right here. So it returns the card, and this card is the card object that's being done. So now player card is actually a card object. So now you can use the card class methods on player cards. So we first get to the score. Like we first go and get number and add it to the score because that was necessary, and then we go and extract the color, and for each color we assign it a score. Okay, so that's a little bit tricky, but I think we can gonna do that. Okay, so we're gonna go to question 3 underscore n22. Okay. So a binary tree consists of nodes. Each node has a left pointer, a data, and a right pointer. The binary tree is stored using a global 2D array. So array nodes. So we got to do is array nodes. Okay, so it's 0 to 19 is 20, and we got obviously three columns over here. So it stores integer values. So we're going to be doing is for 0. It's got 3 columns, so times 3 for x in range, and it's got 19 rows, so that 0 to 19 is 20. Okay, so left pointer is first node, data, and then we've got right pointer for the first node, and we need to assign each of them -1. Now I'm not going to do that because right in the next question you can see that we have got some data values that we need to assign. Okay, free node is initialized to C and root pointer is to 0. So in the exam you should do this and paste it in an evidence document, but for now I'm not going to do it because I know that I have to kind of work on with some of this data. Okay, so what we're going to be doing is we're going to go to arrayNodes.append, okay, and then just append it in the following fashion. There you go. Okay, so you're just going to be appending it in this following manner. Okay, arrayNodes.append, then we've got 215, -1, right? So then we've got -133, 33, -133, -194. -194. Then arrayNodes.append, -194, then -1, 10, -1. Then we also have -1, 58, 1, and finally -1, -1, -1. So that's like the end of the tree. Okay. Free node, right? So you got a free node initialized to 6, and then you've got a root pointer that's initialized to 0. Great. So now we have to go ahead and do is we want to put a recursive pseudocode function that searches in the binary tree for a given value. So it has already given us the pseudocode. So you want to go ahead and do is def search value, and then just follow the pseudocode. Pseudocode takes root and value defined as integer. So you're going to do root. Then we've got value to find as integer. And then if root is 1, then so that's the base case. If root equals to -1, then we want to just return -1. Else, okay, so we got to do is an if statement. So we can just do elif. Then we got to do is array nodes. Then we got to do is root, and you want to check the data of that array is equal to value defined. That means if it's at the root, so then we just want to go ahead and return the root itself. Okay. And then if this array nodes root, is, going to -1. It means return -1. That means the binary tree is empty. Okay. Then the recursive call takes place if array roots this value defined. So if it's going to be, then you got 0. So we're going into the left node, right? So if you say array root once if the data is less than the value to find, then you need to go to the left node because that's how the binary tree, general binary tree is arranged. So if array root one is greater than the value to find, right? If it's greater, then it's going to go to the left side of the tree. So then we want to just go ahead and do is return search value. So in this case, we want to go ahead and do not the root, but we want to go to array nodes root dot 0. That means we want to go to the left pointer and do value to find, right? And then if array node root 1 is greater than value to find, that means we're going to go to the less than, sorry. That means we have to search values that are greater than that. So we want to go to the right side. So search value array nodes root 2 and value to find. Okay, so that should be the recursive call, and that's the end of the function. The visit left. Okay, so a post order traversal function needs to be done. So in a post order traversal, it's going to visit left, right node and output the root. So first it visits left, then it visits the right, outputs. Okay, so it visits this and outputs a root. All right. So we first visit the left, outputs it. We go to the right, outputs it. Then we again go to the left, outputs it, right, outputs it, and then finally the root. So that's a post order traversal. So first visit, output, starting from the left, right? So visit, output. So it needs to go to both of these and visit them and then output the values for left and right accordingly. So do it for the post order. So the post order takes a root node as parameter. Okay, so we want to do is deft post order ORDR. I hope order spelling is actually correct. So it takes a root as a parameter, right? It takes a root node as parameter. So we want to go ahead and search array nodes because that is our binary tree in this case. So we first need to go ahead and visit the left node. So if array nodes root 0 is not equal to -1, that means not empty, then we need to go ahead and call post order again because we need to recursively keep searching for that. So we're going to go to array nodes root. So we have visited that already. So we're going to go and visit the kind of left pointer for that root. So obviously root is going to be updated every time because you're going. So now root, the value of the value that's going into post order is not root, but it's the left node. Okay, and it's going to keep on happening recursively. Then we want to go ahead and visit the right node. Okay, and you should be studying these algorithms as part of your syllabus. Okay, so then we're going to go for another post order traversal with array nodes root 2. Okay, and then once you have visited all those, we just need to go ahead and print array nodes root, and you're going to go for a 1. Okay, so that's it for post order. So now the procedure says call the function search value to find the position of the number 15 in the tree. Use the result from search value to output either the index or an appropriate message so that the value was not found. Okay, so you want to go ahead and use search value. So found. If found, let's just call it if found. You shouldn't actually name it with if, so let's just call it search result. Okay, and then we're going to go for search value. So we're going to be taking root pointer, and the value to find in this case is going to be 15, right? So we want to go ahead and just do 5. We're going to just go ahead and do 15. Okay, there's a result from search value. So if search result is equal to -1, right? Because if it's not found, we're returning -1s in this case. Then we're going to output the message, the value was not found. Else, if we're getting any other value, that's going to be the index, obviously. So we're just going to go and print value was found at is. Just put a space, and then that's going to be the search result. And call the procedure post order. So print, just name it force order. I forgot the spelling of traversal, so I'm just going to go a little bit to the top. Traversal, right? And then just go ahead and let's just call force. And it takes root as parameter, so I'm just going to put root pointer in there. Okay, so list attend takes exactly one argument only. Okay, so the append function is not going to work like this. So what we need to do, all right, is just go to array nodes now, okay, and we got to do this. Okay, so 125. Okay, then we got to do is 2 comma 15 comma -1. Now I am looking at the question, okay, on a different screen connected to my computer. I'm just going to putting these values once again, but this time I gotta just do this once more. Just give me a second. I should be done as fast as possible. And then we've got -1, 9, 4. Then we've got -1, 10, -1. Then you've got -1, 58, -1, and then you've got -1, -1, -1. I think I've added the values correctly. Okay, we have a few issues. So maximum recursion depth exceeded. Search value. Okay, so what's wrong with search value over here? Array nodes, it's taking in array nodes with the root of 2. If it is less than, it's going to be doing the value to find. Okay, so if array nodes is going to be greater than value to find, then we just want to return search value array node root 0 value to find. Okay, over here if we found it, then we should have returned the root, and if it is going to be less than over here, then value to find. Okay, so then we've got list, and so that's the data we're checking. Okay, that should be correct. And then we've got return to this. Let's check the pseudocode, right? So it's going to, okay, if I change this to an elif statement, okay, it's going to the maximum recursion depth exceeded. It should be good with an if statement. So let's go and recheck the algorithm just for a second. So if you've got -1 to the root, actually, then it's going to be that with the root itself. Okay, so I'm checking this with root every single time. But again, I'm updating the value of root. So in this case, it starts from the root and then goes to it. So that's the second value in the root. Array nodes. Okay, I'm getting a recursion depth exceeded. Search value, search value, search value. Search results. Okay, so it's going to this area. In this statement. Okay, so particularly, so the root pointer is 0, right? So the root pointer is basically 0. So the first data is 20, so it should have entered the left node. That's going to the right node. Okay. I think I've changed that, but I've got no luck with it. Okay, if so, got the value to find. Let's see what I've done. So if root is -1, it just ends. If we found the value, then that's great. If we did not find the value, it is, if it's -1 actually from the root, then it's going to be returning -1. Array nodes value to find. So it takes a root as parameter. So this is, in this case, it's just going to be root, but it should be updated. Okay, if it's -1, this is interesting. So if array root, if the data is less than in this case, then it goes to the, yeah, that shouldn't be the case. Okay, this is interesting. So we go to return array nodes of 2. Space. Okay, did I put the data in correctly? So we've got 125. Sometimes that could be an issue. So 125, then you've got 215 -1, then you've got -133, then you've got -194, -1, 10, 58. So 10, 58, and then all negative ones. Okay, so it's the free node is initialized to 6. Interesting. Okay, then it returns root is 1. Then we gotta go ahead and do a -1. Root is 1, then you got a -1. If this is the case, validly fine, then we just return the root. Else it is still -1. That is the case. So okay. Else if, okay, then outside, if array nodes root, then return root less than value defined, then return search value defined. Alright, I think I'll be needing a little bit of time to troubleshoot this. Alright, so it actually did take me long enough, but notice I've written the name of array nodes incorrectly. And yeah, so this should be array nodes. I think it should work now. There we go. That was the only mistake. That was just a spelling mistake. That's it. All right. So hope you enjoyed this video, and this is the complete solution for the 2022 paper, and I'll catch up in the next video. Peace.